Hey everyone, this is FixReef, and today we have this Gen 4 XR15 that came in with a problem, a typical problem these days when the light shuts off at higher intensity due to one or more channels failing. In this particular case, the customer said that the green channel at high intensity shuts off the light. In other words, if you individually bring down the intensity of the one individual channel to pretty much zero, and then bring everything else up to 100 or close to 100% intensity, the light is perfectly fine. The moment you start bringing up the intensity of the failing channel, the light shuts off. And the reason that happens is because the light goes into protection mode where it prevents the damage to the main board, because it senses that the channel in question is consuming too much current or incorrect amount of current, and assumes that it's shorted. And if it's shorted, it shuts off the whole thing. Anyway, let's open it up and see what we have inside. Everything looks fairly clean. No water damage. Let's remove the lens. Okay. This looks very, very clean, except for maybe one hole over here has a little bit of what appears to be corrosion, but other than that, doesn't look too bad. Let's just plug it into the power and see if right away we can tell which channel is causing trouble. Okay, I've heard the click, but I'm not seeing anything on. Let's see. Okay. All right. Looks like everything is on except for two LEDs, which are the green LEDs right here. 1 and 2. And we're increasing intensity. It's getting real bright. And kind of starts flickering. I'm not sure if you can see this, but it starts flickering and then shuts off. And then it attempts to start again, starts flickering and shuts off. And again, flickers and shuts off. So I think we have our suspect. Let's do some testing on the suspect LEDs. Here's one. And the LED is on. Doesn't mean much, because if the other one is shorted, both of them are not going to work. And this one is working as well. So it appears that the LEDs themselves are working just fine. Then the problem must be with something else. Notice, since I'm here, that in the Gen 4 XR15 light, they didn't have enough room to put one main board on just one side. Remember that from the very beginning, from the original Gen 1 XR30s that came out in ancient times, they always had two areas for the boards. And in fact, in the very early versions of the lights, they had the wiring on both sides, assuming that eventually they will need to move over to the second bay to hold additional boards. Finally, by Gen 4, we got to the point where we ran out of room in XR15, and that board had to be split across two different sides. You can tell that this smaller board is primarily responsible for power and fan, and the larger board would be individual LED channels. Anyway, so while testing this, I have noticed something interesting. Before taking this board out, while the individual LEDs, green LEDs, work just fine, it doesn't seem like I can actually power them through the test points, which I should be able to for individual channels, for some of the smaller individual channels anyway. So the traces from the green LEDs happen to go across here. And you can see that there is some kind of odd corrosion going on underneath here, which may suggest that the issue is with the traces and not with the main board itself. Although at this point I can't rule out anything. To finish these diagnostics, let's just remove the board, eliminate the effect of the main board onto the LED cluster, and just test it that way. Need to be careful with this board. It's disconnected. Here's our LED cluster, and let's test everything again. Once again, green LEDs work. All is good. You can see that I can now power some channels. This UV is coming up, but the green channel doesn't come up at all. The red channel comes up, but the green channel doesn't come up. However, if we attempt to power the green channel through this, it kind of works. This suggests that the negative trace is not conducting. The negative trace comes out of here, goes around, and goes right along the way of this opening here. So let's get under the microscope and let's take a look at this opening, because I suspect that the trace has been broken somewhere in this area. Okay, so I have restored the trace that was damaged. I have covered all of the other damages with the mask. And now that I'm looking at it, I want to make sure that I've repaired everything here. This doesn't look too good unless this is just additional salt. There are two traces here that seem to have received corrosion. That seems to be good. Alright, the board is done, the mask is dry, so let's take a look and see if we fixed the problem. Alright, looks like the green channel is working. Looks like the red channel is working. That's great. Alright, it appears that the light's been fixed. Let's put it together, give it full power and see if it lights up. Alright, now that it's assembled, let's give it some power, turn it on, and see what happens. Alright, looks like the blue channel's on, the white and the red and the green channels are on, the UVs and everything else is on, and it's staying on. Now let's increase some intensity and see if it will shut off again. Now this is almost full intensity. I think we have it fixed. It's staying on and it's not shutting off. Oh, this is great. Okay, well, the light is fixed. Now let's go over what happened here. At first I thought that the problem was with one of the LED channels, perhaps one of the LEDs that are broken, but it turned out that all of them are actually working fine. The problem turned out to be with the traces around this one small area, because obviously salinity and corrosion got in there somehow, and it corroded all the traces. So all we had to do is just repair those traces, make sure that everything connects, and it started working again. Well, this completes the repair. If you enjoyed this, please like and subscribe, and I will see you next time.